Okay, I'm going to do my best to try to show you some things on lesson 3.2 in my open math. And the first question asked about how do you graph a piecewise function? Well, piecewise function generally means that you're going to have two different shapes inside your graph. So you might have y equals mx plus b for x is greater than 2, whereas you might have y equals x squared for x is less than or equal to 2. So, oops, sorry about that. So what that would look like, well, greater than or equal to 2 would be a line. So just say you might have something like that over there. You have a line. And less than or equal to 2, you might have a parabola, kind of like that, right? The solid dot there. So that's kind of like what a piecewise function looks like when you graph it. Now, the next one asks us to talk about the domain of y equals x cubed, y equals, oh, not cubed, y equals the cube root of x, and y equals the square root of x. Now for those, the domain, so again, domain, what does that mean? That basically means that what number could x be? Well, in the case of y equals the cube root of x, I could have a negative or a positive in there. So that's going to be negative infinity to positive infinity. So what does domain mean again? All the possible values that x could be inside, that x could be in the problem at all. So we're concerned about not having negatives inside the root. Well, in terms of the square root, this one down here, that one we have to have x is greater than or equal to 0. So that means it's going to be 0 to positive infinity, because we can't have anything in here that's negative square root. So square root and cube root have different domains. That's what we're saying right there. The third one here, when describing the set of numbers using interval notation, when do you use parentheses and when do you use a bracket? So in case that was not already clear to you, soft bracket does not include, say you have 2 to infinity. That'd be like this. If you have 0 here, you have 2 here. That's an open circle shaded to the right. That means any number greater than or equal to 2. So greater than 2, not including 2. Okay, but when you use the bracket, like this, that includes the 2. I just want to make sure you guys know that. I know it's pretty clear because we've probably brought this up in conversation before. So when you either have a shaded line or a shaded dot and it's going in one direction, it includes it, hard bracket right there. That's what we need to keep in mind. Next one here is what is the only value where x cannot be in the domain? 1 over 3x plus 7. Okay, so if we have 1 over 3x plus 7, again, what do we have to worry about for a domain? We have to worry about x being in the denominator, 0 being in the denominator, or square root being negative. So in this case, 3x plus 7 cannot equal 0. So we solve for that value, and then we say that's the value that x cannot be in the domain. So 3x cannot equal negative 7. So x cannot equal negative 7/3. So therefore, when we write our domain, we always start with negative infinity on the left, go up to negative 7/3, and put a soft bracket so it doesn't include, then put a u, which means and then negative 7/3, comma, infinity. So that includes that. Everything, domains include every value of x except for negative 7/3. That's what that means. All right, let's take a look at the next one. What do we have next? So which of the following graphs corresponds to negative 4 infinity, hard bracket? Negative 4 infinity. So if we have negative 4 infinity with a hard bracket like this, infinity always has a soft bracket itself. As we just said, if we put 0 there and negative 4 here, that means we're going to have a filled in dot and go everywhere to the right. Okay, because that's going to include -4 right there. That's what we're saying. All right. Let's take a look here. What's the final graphs of -5, infinity? So we have -5, infinity. So we have -5, infinity soft bracket. That's going to be a hollow dot, right? A -5, right there, -5, and going to the right because it's going to infinity. Every number greater than -5 and less than infinity. Okay, so that's what we have there. Next, we have find the domain of the function, use interval notation. So it's x plus 5, x plus 9. So we have x plus 5, x plus 9. So we have to know what are the possible values for the domain using interval notation. Well, we can kind of put any value in here for x that we want. So do we have x in the denominator? No. Do we have a square root? Okay, no. So do we have any restrictions of the domain? No. So we're going to say domain, okay, x could go from -infinity to +infinity, all right? No restrictions right there. Don't need to plug anything in there. So it can equal 0. There's no denominator here. There's no square root here, so we're okay there. So go -infinity to +infinity. Okay. Next, find the domain of this feature. Okay, so we have y equals the square root of 3x minus 5. Y equals the square root of 3x minus 5. So what does that mean? That basically means that x cannot, we can't have a negative value inside the square root. All right, so that's what we look out for. All right, so what does that basically mean? That means that this cannot be negative. So we have 3x minus 5 has to be greater than or equal to 0. So it can't equal 0, that's fine. So 3x has to be greater than or equal to 5. So x has to be greater than or equal to 5/3. So what does that mean? That means when we write it out, we have a hard bracket because it includes 5/3 and comma and then soft bracket infinity. That's what that means. Moving on up, as they say in the Jeffersons. All right, y equals square root of s squared plus 9. Okay. Y equals the square root of s squared plus 9. Okay. So again, this has to be greater than or equal to 0. Square root is one of the two cases where our domains can be limited. So we're going to have s squared plus 9 has to be greater than or equal to 0. So that means s squared has to be greater than or equal to -9. Well, that's pretty much going to be anything because when you square it, it's going to be positive, and we're assuming real solutions here. So what does that mean? That means it could be -infinity to infinity because any negative number or positive number I put in here, when I square it, it's going to be 0 or greater, which is greater than or equal to -9. So check, that could be anything there. All right, moving on. We have 14 square root -9t minus 8. All right, equals y. They call f of t, but it's basically y. So what does that mean? We're looking for right around to find the domain. So again, we're seeing domain. Domain. So do we have a square root? Yes. Do we have a denominator? No. But so we have to make sure that this has to be greater than or equal to 0. So square root of -9t minus 8 has to be greater than or equal to 0. So when we square that, we're going to get -9t minus 8 has to be greater than or equal to 0. We square both sides, so that's what we did there. Okay. Can I get the other ink? I don't know. Maybe not. I'll play with that later. Anyway, so -9t has to be greater than or equal to 8. And t has to be less than or equal to -8/9. Be sure to reverse your symbol when you're dividing by a negative here. So here you're dividing by a -9. Whenever you divide by or multiply by a negative number, With an inequality, you reverse the direction of the symbols. So see here, Pac-Man's facing to the left. And, oh, right. Did I switch it? I said it, but I didn't switch it. Okay, so did I write my answer here? Let's see. So I started out with greater than. It's going to be t is less than or equal to negative 8/9. See? So it's good to have mental math to check your answer along the way. So t is going to be less than or equal to negative 8/9. I want interval notation. So that means you saw we start with the lowest value to the left, start from negative infinity, and go up to and including negative 8/9. There you go, hard bracket, because it includes that negative 8/9. Moving on here. So this is the number, what's this, 10 or something? What do we have? We have f of x is equal to y is equal to, so we have negative 12x plus 10 over negative x minus 12. And again, they're asking us to find the domain, so we only care about the denominator. Do we care about the numerator? Not at all. It doesn't matter what that is, so get that out of your mind. We just know that the denominator cannot equal 0. It's one of the two places our domain can be restricted. So negative x minus 12 cannot equal 0. So negative x cannot equal 12. So x cannot equal negative 12. So therefore, when we write our domain, we always start with negative infinity, okay? And we go up to any value that's not included, so negative 12 cannot be included, so soft bracket. And you guys remember, then we put a u there for union, and we start with negative 12 and then go towards positive infinity, because the only number that doesn't work is negative 12. And you see how we have soft brackets here, so that tells us we're going to be okay, we'll be fine there. It's getting a little long, I'm going to stop here and then continue with the rest of the problems in a bit. Maybe I'll do one more, let's see. We did a bunch. Okay, I think we went down to like 10 or so. Yeah, we'll do another one. What the heck? Okay. So what do we have? We have y equal to square root of x minus 3 over square root of x minus 5. Now we have to make sure that, now we have two things here at the same time. We have a denominator that cannot equal 0, and then we have square roots that have to be greater than or equal to 0 because they're square roots. So one thing at a time. We know that x minus 5 cannot equal 0 because it's in the denominator. We can't have 0 in the denominator. Normally we can have a square root of 0, but just not in the denominator. So x minus 5 cannot equal 0, so x cannot equal positive 5. That's one thing that's true. We also have to make sure that x has to be, now this has to be also greater than or equal to 0. So x minus 5 has to be greater than or equal to 0 because it won't be defined that way. So x has to be greater than or equal to 5. So basically, if we go back up, x cannot equal 5 or anything smaller than 5. So x has to be greater than 5. You can't have like a 4 in here because that'll make a negative 1 down here. Right here, you can't have a 4 in there. Likewise here, x has to be at least 3. You can't have a number that's less than 3. So if you take a look at all the restrictions together, we have x has to be at least 3, x has to be at least 5, x can't equal 5, so therefore we have to put that all together into one statement. So what we do is, let's make a little picture just to make that clear for you. If we made a little picture, you'd see together, if x has to be greater than 3 and x has to be greater than 5, we have to make sure everything's included all together. X can't equal 5. So basically, x could be greater than 3 and less than 5 in here. Can't equal 5, and then it has to be greater than 5. So we have to write that all in one statement. Okay. So what we're going to do there is we're going to say negative infinity up to 3, soft bracket, and 3 to 5, soft bracket, and 5 to positive infinity. Okay. That's where we need to stop now because the video is getting too big and maybe won't publish, so I'm going to stop right there. I'll catch up with you in the next video. Bye.